In this section, section 5.2, we're going to be talking more about rational functions. I have to be honest, these graphs are going to be a little bit weirder than in section 5.1. Okay, so the first thing we're going to talk about are our asymptotes. You have two kinds of asymptotes, vertical asymptotes and horizontal asymptotes. So remember, an asymptote is a line that the graph is not going to cross. Okay, so the vertical lines that they don't cross are determined by looking at the denominator. So you're going to set your denominators equal to 0 and then and solve it. And that will tell you where the vertical asymptotes are. A horizontal asymptote is a little bit different. You're going to determine it based on the degrees of the numerator and the denominator. So let's look at the three different cases for a horizontal asymptote. In example number 1, case number 1, if you notice, the numerator has a degree of 2, the denominator has a degree of 1. So the top degree is bigger than the bottom degree. Anytime the top is bigger than the bottom, you're not going to have a horizontal asymptote. Now, if it's reversed so that the big number is on the bottom, so you have a 1 on the top and a 2 on the bottom, or a 10 on the top and 11 on the bottom, as long as the top is bigger than the bottom, then your horizontal asymptote is always going to be y equals 0, which is your x-axis. Okay? And then the third case is when they are equal. See how those are equal, x squared and x squared? When they're equal, it's sort of cool. It's going to be the leading coefficient of the top divided by the leading coefficient of the bottom. So in this case, it's going to be y equals 3/2, or a horizontal line at about, what is that, 1.5? Okay, now I told you this. These graphs are a little weird, so you may have holes in your graph. In other words, it's going to basically be a straight line, except you'll have a hole in it. That only happens when you have identical factors on the top and the bottom. So there is a value that creates a 0 on the top and a 0 on the bottom. For example, if I had, let's say, x plus 1 times x minus 2 on the top, and on the bottom I had x minus 2 times x plus 5. Notice how these two could cancel each other out. Okay, so you have the exact factor on top that you do on the bottom. Anytime you can cancel stuff out like that, you're going to wind up with a hole in your graph. So now let's talk about your intercepts. You can have x-intercepts and y-intercepts. So x-intercepts, you've determined those by setting the numerator equal to 0. So numerator is going to be 0. For the y-intercepts, you're just going to plug in 0 and then just simplify, and that'll tell you what the y-intercepts are. So in summary, your vertical asymptotes, to get the vertical asymptotes, you're going to set the bottom equal to 0 and then solve it. For horizontal asymptotes, you're going to look at your degrees, okay? So remember, if the top is big, top is greater than the bottom, that was case 1 and there's none. If the bottom, if the top is smaller, then the, I've said it. If the top is smaller than the bottom, then it's y equals 0. If they're equal, top is equal to the bottom, then you'll have y equals the leading coefficient over the leading coefficient. Okay? You know you're going to have a hole in your graph if you have identical factors. Identical factors. For your y-intercept, remember, set your top equal to 0 and then solve. And for your y-intercepts, you're going to plug in zeros for x and then simplify it. Okay? So let's do a few examples, okay? So the first one, we just need to find the vertical asymptotes. So when you're finding the vertical asymptotes, that's this right there, okay? So we just have to be careful and make sure we label them correctly, because this one has a little trap. See how these go up by 2s, 2, 4, 6, 8, and they go down by 2s? That can make you mess up. So my vertical asymptote is going to be x is -4 and x is +4. My horizontal asymptote, I'll do that one in green. That's a y equals graph. Okay, so y equals, and again, you have to be careful because it's going up by 4, so 2 and 4. So it's going to be a horizontal y equals 2. So to find your domain, so the domain is whatever your x can be. So your domain is going to be this part right here. So it's going to go from -infinity all the way up to -4. -infinity up to -4, but it can't be -4. Notice that's where our asymptote is. It's going to be in the middle, which is going to go from -4 to +4. And then finally, the end, which is going to go from 4 to infinity. And again, you can put semicolons in there, or you can put your union, however you want to connect those. All right, let's look at another example. So with this one, whenever you're finding the asymptotes, whenever you're answering these questions, it really does help if you have the top and the bottom already factored. So that's the first thing I'm going to do. When you factor the top, this is what you're going to get. Take out the 3 because they have a 3 in common. Then you'll have x plus 2 and x minus 4. On the bottom, I can't take anything out, but I'll have 5x minus 1 and x minus 5 when I factor those. That's just going to help us out a little bit, because let's start with our vertical asymptotes. Vertical asymptotes, remember it said set the bottom equal to 0. So now I already have my bottom factored. So I'm going to set that equal to 0 and solve it. So I have 5x minus 1 equals 0. So that's going to turn that into what? When I move my 1 over, I'll get 1/5. And then this one, x minus 5 is a 0. So that gives me x equals 5. So my vertical asymptotes are going to be x is 1/5 and x is 5. So I've got 2 vertical asymptotes there. Okay, now let's look at the horizontal asymptotes. For the horizontal asymptotes, remember you're looking at these, those exponents. Notice they're exactly the same. So when they're the same, you use the leading coefficient. So that's going to be your horizontal asymptote. Notice it's y equals. Okay. Now to get your, let's get our x-intercepts. To get your x-intercepts, see what it says up here? X-intercepts, we look and make the top equal to 0, right? So we're going to make the top equal to 0. Notice I didn't say there's any holes in there because there aren't. Notice all of these factors are different, so you can't cancel any out, okay? All right, so let's go back and do our x-intercept. Okay, and for x-intercepts, we said we're going to let the top equal 0. So I've already factored it. That's what I mean. It just helps if it's already factored. It saves you a little bit of time later. So what would make that 0? A -2. And what would make that 0? A +4. Now you could set them equal to 0 and solve if you want. So we have 2 intercepts, -2 and +4. Usually write them as a point. The y-intercepts, remember for the y-intercepts, we're going to just plug in a 0, okay? So for y-intercept, I'll plug a 0 in all these places, here and here and here and here. Now notice when I plug a 0 in, that is going to just make that cancel out, and that cancel out, and that cancel out, and that cancel out. So that's all I've got left. So I would have, the y-intercept is going to be negative 24 fifths. Okay, so for negative 24 fifths, we're going to write that as a point. I'm just going to try and, whoops, erase that. Okay, so I'll write it as a point. So that's going to be the point 0 and negative 24 fifths, which when we actually would graph that would be what, negative 4 and 4 fifths. Now, whenever you're doing the domain, it really helps if you just go ahead and graph. I'm going to go ahead and, I mean, not truly graph it, but at least set up my my vertical asymptotes. So my vertical asymptotes are at 1/5, so that's going to be here, and 5, so something like that. So I know that's 1/5. No, that's 5. So my domain is going to be in this part right here, because we're just talking the x's, not y's. So domain is going to go from negative infinity to 1/5. Negative infinity to 1/5. Then in the middle, it'll go from 1/5 to 5. 1/5 to 5. And then, of course, the last one will be 5 to infinity. And again, I usually put u's in between there. So we're going to take a break and let you review what we just did, and then we will start doing our steps to graphing.